Hello, curious minds. Welcome back to Project Silence Prodigy, your one-stop solution for all your project management and mechanical engineering needs. I'm Govind, a certified PMP and mechanical engineering professional with more than 25 years of experience in the power and energy sector. In our project management knowledge area series, we have already learned about project integration management, which is coordinating all project activities. Project scope management, defining the work that needs to be done. Project schedule management, completing the project on time. Today, we move to lesson 4, project cost management. And the theme for today's lesson is budget control is survival. Think about it for a moment. No matter how well a project is planned, if it runs out of budget before the work is finished, the entire project can come to a stop. Similarly, if a project is completed on time but goes far beyond its approved budget, it is generally considered unsuccessful. On the other hand, reducing cost by compromising the project scope or quality is also not the right approach. A successful project is one that delivers the required scope and quality while staying within the approved budget. In this lesson, we will learn how project managers estimate project costs, prepare the project budget, establish the cost baseline, monitor project spending, and control costs throughout the project lifecycle. We will also explore the PMI recommended cost management processes and important concepts like cost estimates, cost baseline, contingency reserve, management reserve, earned value management EVM, cost variance CV, cost performance index CPI, along with many practical techniques used in real world projects. So let's get started. Project cost management. Project cost management is the process of planning and managing project cost so that the project delivers maximum value within the approved budget. In simple words, it is all about making sure that we spend the right amount of money at the right time to successfully complete the project. Remember, the objective is not simply to spend less money. The objective is to deliver the required project scope and quality while staying within the approved budget. Project cost management mainly focuses on three important areas. First, it focuses on the cost of the resources needed to complete the project. For example, suppose you are building a house. Before construction begins, you identify all the resources you will need, like cement, steel, bricks, labor, electrical materials, plumbing materials, and construction equipment. Second, it focuses on estimating, budgeting, and controlling project cost. Once you know the resources required, you estimate the cost of each item and prepare the overall project budget. Let's say the total estimated cost of building house comes to $300,000. This becomes your budget. During construction, you regularly monitor your spending and compare it with the planned budget to ensure costs remain under control. Third, it focuses on delivering the project within the approved budget. Finally, your goal is to complete the house within the approved budget of $300,000 while maintaining the required quality and completing all the planned work. If the house is completed successfully without exceeding the budget, then your project cost management has been effective. Project cost management processes. According to PMI, project cost management includes the processes involved in planning cost management, estimating cost, determining the budget, and controlling cost so that the project can be completed within the approved budget. Let's understand these processes one by one. The first process is plan cost management. Before estimating any cost, we first need to decide how the project cost will be planned, monitored, and controlled. In other words, we establish the rules for managing the project's finances. During this process, the questions may come up as: how will project cost be estimated? Which currency will be used? How often will project cost be reviewed? What level of cost overrun is acceptable? And how will cost performance be reported? Let's take one real life project example to understand this. Suppose your company has been awarded a turnkey project, which is to install a 50 megawatt power plant comprising 6 large diesel generator sets along with its all required auxiliary systems. Before estimating the project cost, the project manager will prepare a cost management plan. For example, the team decides that all cost will be prepared in US dollars and cost reviews will be conducted every month. And any cost overrun greater than 5% will require approval from senior management. So these guidelines become part of the cost management plan. In simple words, plan cost management does not calculate project cost. It defines how project cost will be managed throughout the project. Once we know how cost will be managed, the next step is estimate cost. In this process, we estimate the cost of every activity and every resource required to complete the project. Resources may include labor, material, equipment, transportation, accommodation, subcontractors, cranes, and many other project expenses. Let's estimate the turnkey EPC cost for our 50 megawatt engine based power plant. So here we can see the first activity, engine and auxiliaries. We are planning to install 6 engines and related auxiliaries like alternators, radiators, pump, filters, turbocharger, pipelines, everything. So estimated cost for these equipment is 35 million USD. Logistic and transportation. The estimated cost is 3 million USD. Next activity is civil works, which means powerhouse building, engine foundation, tank foundation, control room, roads, drainage. So the cost is around 12 million USD. Next is mechanical work, piping, exhaust system, cooling water, fuel oil, lube oil, air system, firefighting. So costing is around 8 million US dollar. Next activity is electrical and instrumentation work. Cables, switchgear, MCC, transformers, PLC, SCADA, instrumentation. So the cost is around 7 million US dollar. Tank farm area, where there will be HFO tank, diesel tank, lube oil tank, pumps, piping. So the costing will be around 3 million US dollar. And testing and commissioning activity, the costing will be 2 million US dollar. And labor, supervision and project management, estimated cost is 5 million US dollar. So when we add all these individual cost estimates together, the total estimated project cost comes to 75 million US dollar. These estimates help us understand approximately how much money will be needed to complete the project. After estimating the cost of every activity, the next step is determine budget. Here, we combine all the individual cost estimates to prepare the total project budget. The total estimated project cost we calculated as 75 million US dollar. On top of this, to manage the project risk, management also approved contingency reserve of $1 million. If we add this contingency reserve, the approved cost baseline becomes $76 million. On top of this, to handle the unknown risk, we add another $1 million, which is called management reserve. So the total project budget becomes $77 million. This approved budget becomes the financial target for the project. Throughout the project execution, all actual cost will be compared against the approved cost baseline, which is $76 million. In simple words, determine budget answers the question, how much money do we need to successfully complete the project? The final process is control costs. Preparing a budget is not enough. As soon as the project execution begins, the project manager must continuously monitor actual spending and compare it with the approved budget or cost baseline. Let's continue with our power plant project. Suppose after 6 months, according to the cost baseline, the project should have spent a half of the budget, which is 38 million US dollars. However, the actual spending has already reached 40 million US dollars. So this indicates that the project is over budget. Now, the project manager investigates the reasons. Perhaps steel prices increased, fuel cost went up, heavy rainfall delayed the work, or additional civil work became necessary. Once the causes are identified, corrective actions are taken, and those could be like negotiate with suppliers, improve labor productivity, reduce material wastage, optimize resource utilization, and review procurement strategies. The objective is to bring the project back within the approved budget. So control cost means continuously monitoring project spending, identifying cost overruns, and taking corrective actions to ensure the project stays within the approved budget. Cost estimation techniques. Estimating project cost accurately is extremely important because the quality of the project budget depends on the quality of the cost estimates. If the estimates are unrealistic, the project may face budget overruns or funding shortages later. To improve the accuracy of cost estimates, PMI recommends several tools and techniques. The first technique is expert judgment. As the name suggests, this technique relies on the knowledge and experience of experts who have worked on similar projects before. Suppose we need to estimate the cost of installing 6 large diesel engines for our 50 megawatt power plant project. So instead of starting from scratch, we consult a senior project manager who has successfully completed several similar power plant projects. The biggest advantage of expert judgment is that it is quick and practical. However, its accuracy depends on the experience and expertise of the person providing the estimate. The second technique is analogous estimating. This technique uses information from a previous similar project to estimate the cost of the current project. For example, suppose your company did a 40 megawatt power plant project 2 years ago for 60 million US dollar. Now, your company has received a contract to install a 50 megawatt power plant. Since both projects are similar in scope and technology, the previous project can be used as a reference for estimating the new project cost. This method is quick and useful during the early stages of project planning. However, it is less accurate because no two projects are exactly the same. The third technique is parametric estimating. Here, instead of comparing with the previous project, this technique uses historical data and mathematical relationships. For example, suppose we have historical data that constructing an engine foundation cost 500 US dollar per cubic meter of concrete. If the new project requires 2000 cubic meters of concrete, so the estimate cost is simply calculated by multiplying the quantity by the unit cost. Because it is based on measurable data, so parametric estimating can provide a higher level of accuracy, provided reliable historical data is available. The fourth technique is bottom-up estimating. This is one of the most detailed and accurate estimating techniques. Here, instead of estimating the entire project as one item, we estimate the cost of each individual activity or work package separately. Once every activity has been estimated, all these individual estimates are added together to determine the total project cost. Since every work package is analyzed in detail, bottom-up estimating usually provides the highest level of accuracy. We have already discussed bottom-up estimating in last slide when we estimated cost for 50 megawatt power plant installation project. The fifth technique is three-point estimating. Sometimes it is difficult to estimate a single cost because of uncertainty. So instead of using one estimate, PMI recommends preparing three estimates. The first is optimistic cost, which represents the best case scenario. The second is the most likely cost, which represents the expected or realistic scenario. And the third is pessimistic cost, which represents the worst case scenario. Using these three values, we calculate the expected cost. For example, suppose the estimated cost of installing the cooling water piping is optimistic cost is $900,000. most likely cost is $1 million and pessimistic cost is $1.3 million. So using the beta distribution formula, we can calculate the expected project cost. So expected cost will be optimistic plus 4 into most likely plus pessimistic whole divided by 6. So if you substitute the values in this formula, so the answer we get it $1.03 million. So instead of simply assuming the cost is $1 million, the expected cost becomes approximately $1.03 million. This technique not only provides a more realistic estimate but also helps us understand the uncertainty associated with the estimate. Now, let's understand one of the most important concepts in project cost management, which is cost baseline. PMI defines the cost baseline as the approved and time-phased project budget that is used to measure and control project cost performance throughout the project life cycle. The cost baseline is simply the approved budget for executing the project. It becomes the benchmark against which the project manager compares the project's actual spending. As we discussed earlier, for our power plant project, total estimated project cost is 75 million US dollars. Since the project has some identified risk, so the management approves a contingency reserve of $1 million. So cost baseline becomes 76 million US dollars. Another confusing term here is time-phased budget. What it means? Many people think that once the cost baseline is approved at $76 million, the entire amount is available to spend immediately. That is not correct. A time-phased budget means the approved budget is distributed over the project timeline according to when the work is planned to happen. If you see the graph, by month 3, the project plans to spend about $10 million. By month 6, it plans to spend about $38 million. And by month 12, the planned cumulative spending reaches $76 million, which is the cost baseline. This planned spending over time is what PMI calls a time-phased budget. If you look carefully at the graph, you will notice that it forms the shape of letter S. That is why this is called an S curve. During the first few months, the curve starts slowly as most of the work involves site preparation, excavation and civil foundation. So project spending is relatively low. As the project moves into the middle phase, the graph becomes much steeper. Expensive activities like purchasing the equipment, auxiliaries, piping, electrical installation will take place. Therefore, project spending increases rapidly. Towards the end of the project, the curve flattens again. The focus shifts to testing, commissioning, documentation and handing over. Since very few major purchases are made in this stage, the spending rate slows down again. If we talk about management reserve, it is the additional amount added on the cost baseline, which is reserved for the unforeseen risk or unknown unknowns. Adding management reserve to cost baseline gives us the total project budget. Now comes another important topics in project cost management, which is earned value management or simply EVM. Instead of memorizing formulas for these terms, let's understand them using our 50 megawatt power plant installation project. Suppose our project has a planned duration of 12 months and approved cost baseline, which is also called the budget at completion or BAC, is 76 million US dollars. Now imagine we are reviewing the project after 6 months. According to the original schedule, by now 50% of the work should have been completed. However, the actual project status is slightly different. Only 45% of the work has actually been completed, and the company has already spent $40 million. Using this information, let's understand every EVM term one by one. BAC, budget at completion. BAC simply means the total approved cost baseline for the project. It represents the total budget that has been approved for completing the project. In our example, the estimated project cost is $75 million. After adding the $1 million contingency reserve, the approved cost baseline becomes $76 million. And this is the BAC, which is equal $76 million. This is the total planned budget against which project performance will be measured. The second term is planned value or PV. Planned value answers a very simple question. According to the original plan, how much work should have been completed by today? Here, we are talking about the planned work, not the actual work. In our project, today is the end of month 6. According to the schedule, the project should have completed 50% of the total work. Since the total approved budget is $76 million, so the planned value becomes 50% of $76 million, which is equal to $38 million. This means that by month 6, we expected to complete $38 million worth of work. Now let's move to earned value or EV. This is where many people get confused. Earned value does not mean the money we spend. Instead, earned value represents the budgeted value of the work that has actually been completed in our project. Only 45% of the work has been completed. So earned value equals 45% of 76 million, which comes to $34.2 million. Which means the value of the completed work is only $34.2 million. The next term is actual cost or AC. This is the easiest one. Actual cost simply means the real amount of money that has been spent. Suppose the finance department tells us that the project has already spent $40 million. Therefore, actual cost or AC equals $40 million. Now, let's compare these three important numbers. Our planned value is $38 million. Our earned value is $34.2 million. But our actual cost is $40 million. Immediately we can see two things. First, the value of completed work is less than what we had planned. Second, we have spent more money than the value of work completed. SV, schedule variance. The formula is SV equals EV minus PV. In our project, SB equals 34.2 minus 38, which comes minus $3.8 million. A negative schedule variance tells us the project is behind schedule. Next, CV, cost variance. The formula is CV equals EV minus AC. In our project, 34.2 minus 40 gives us minus $5.8 million. A negative cost variance means the project is over budget. We have spent $5.8 million more than the value of the work completed. SPI, Schedule Performance Index. Instead of measuring the difference, PMI also measures efficiency using an index which is called the Schedule Performance Index or SPI. The formula is SPI equals EV divided by PV. If we substitute our project values here, 34.2 divided by 38 gives us 0.90. An SPI of 1 means the project is exactly on schedule. Greater than 1 means ahead of schedule. And less than 1 means behind schedule. Since our SPI is 0.90, the project is progressing at only 90% of the planned rate. CPI, Cost Performance Index. It measures the cost efficiency. The formula is CPI equals EV divided by AC. If we substitute the values, 34.2 divided by 40, which will give us 0.86. This means for every $1 we spend, we are getting only 86 cents worth of planned work. A CPI less than 1 indicates poor cost performance. EAC, Estimate at Completion. Now suppose management asks, if we continue performing like this, what will be the total project cost? This is called the Estimate at Completion or EAC. The formula is EAC equals BAC divided by CPI. If we substitute the values, 76 divided by 0.86, which will give us $88.4 million. This means if our current performance continues, the project is expected to finish at $88.4 million instead of what we planned $76 million. ETC, estimate to complete. The next question becomes, how much more money will we need to finish the remaining work? This is called the estimate to complete or ETC. The formula is ETC equals EAC minus AC. That becomes 88.4 minus 40, which equals $48.4 million. So we still need about $48.4 million to complete the remaining work. VAC, variance at completion. Next, management wants to know how much over budget will the project finish. This is called variance at completion or VAC. The formula is VAC equals BAC minus EAC. If we substitute the values, 76 minus 88.4 equals minus $12.4 million. This tells us that if nothing changes, the project is expected to exceed the approved budget by approximately $12.4 million. TCPI, to complete performance index. Finally, suppose management says we still want to finish within the original budget. Now the question becomes, how efficiently must we perform the remaining work? This is called the to complete performance index or TCPI. The formula is TCPI equals BAC minus EV whole divided by BAC minus AC. If we substitute the values, we get 1.16. What does this mean? It means that from today onwards, for every $1 we spend, we must produce $1.16 worth of planned work. Since our current CPI is only 0.86, so achieving a TCPI of 1.16 will be extremely challenging. The project manager will need to improve productivity, reduce waste, optimize resources, or negotiate lower cost to recover the project. And that brings us to the end of lesson 4, project cost management. Remember, good cost management is not about spending the least amount of money. It's about spending the right amount of money to deliver the required project scope and quality. In our next lesson, we will move on to the another important project management knowledge area, project quality management. If you found this video helpful, please like, share and subscribe to Project Excellence Prodigy so you don't miss our upcoming lessons. Until then, keep learning, keep growing and keep managing your projects with excellence. Namaste, goodbye, Sampai Jumpa.